back to the real number system. In this video, we're going to talk about section 7.3 and repeating decimals. So let's get started. There are two types of real numbers. We have what are called rational numbers and what are called irrational numbers. In this course, we have been discussing rational numbers. So that means that our number can be represented in a fraction form. The word irrational just means that a number cannot be represented in a fraction form. When we convert rational numbers to decimal form, one of two things happen. They either form a terminating decimal. We looked at terminating decimals in sections 7.1 and 7.2, or they form a non-terminating decimal that has a pattern that repeats. Irrational numbers that are written in decimal form will never terminate and they'll never repeat. For example, pi is an irrational number. Now you may know pi is 3.14. That is a rounded version of pi. Pi is actually 3.14159, and that decimal keeps on going. It never stops and it never repeats. The same type of thing happens with square root of 2. In example 1, we're going to convert our fractions to decimal form. Now, if you remember, back in section 7.1, we looked at one method for changing fractions to a decimal form. We're going to look at another method in this section. So in part A, I have 7/8. That means 7 divided by 8. So I'm going to divide 8 into 7. Now you'll notice my decimal place goes after the 7, and I wrote zeros to the right of that decimal place. Remember, if you write zeros to the right of the decimal place, you do not change the value of your number. Don't forget to line up your decimal places when you divide. And 8 does not go into 7, so we have a 0 in the ones place. But 8 will go into 70 8 times, and that leaves us with 6. Bring down your 0. 8 goes into 60 7 times with 4 left. Bring down the next 0, and 8 goes into 40 5 times, and we have nothing left. And so our answer here is 0.875. Now you may be wondering, how did I know to write 3 zeros after the decimal place? Well, I just took a guess. Typically, when I'm dividing to change a fraction to decimal form, I'll write 2, 3, 4 zeros after that decimal place. Let's look at part B. So we have 13 over 25. That means I divide 25 into 13. Again, my decimal place goes after the 13, and I wrote several zeros to the right of the decimal place. Line up your decimal places. 25 does not go into 13, so we have a 0 in the ones place. But 25 goes into 130 5 times with 5 left. Bring down the 0, and 25 goes into 52 times with none left. And so 13 over 25 is the same thing as 0.52 in decimal form. Notice that as long as the denominator of the fraction contains only factors of 2 and 5, the decimal will terminate. Now that's because our decimal system has base 10, and the factors of 10 are 2 and 5. Well, what happens if the factors of the denominator are numbers other than 2 or 5? We have a repeating decimal. So this is a decimal that doesn't terminate, but it has some pattern that at some point begins repeating. In a repeating decimal, the numbers that repeat are called the repetend, and the period of the repetend is how many digits repeat. To write a repeating decimal, we write the pattern out once, and we put a bar over the digits that repeat. So let's look at this. In example 2, we are asked to convert the following to decimals. In part A, I have 2 over 11, so that's 2 divided by 11, or 11 into 2. Notice again that I put my decimal place after the 2, and I wrote zeros to the right of 2. I don't know how many zeros to write, So I just write 3 or 4 zeros. I can always write more zeros to the right of that decimal place if needed. Line up your decimal places. 11 does not go into 2, so we have a 0 in the ones place. 11 goes into 20 one time with 9 left. Bring down the 0. 11 goes into 90 8 times with 2 left. Bring down the next 0. 11 goes into 20 one time with 9 left. And notice that we're starting to repeat. Bring down the next 0. 11 goes into 90 8 times with 2 left. So now I've got my repeating pattern. The 1/8 is the repetend that is repeating. When we write our answer, we write 0.18, and since the 1/8 are the digits that repeat, we put the bar over both the 1 and the 8. The period here is 2 because we have 2 digits that repeat. In part B, we have 5/18, or 5 divided by 18. So I write my division symbol. 18 goes into 5. The decimal place goes behind the 5. And again, I do not know how many zeros to write to the right of the decimal place, so I write 3 or 4 zeros. Line up your decimal places when you divide. 18 does not go into 5, so we have a 0 in the ones place. 18 goes into 50 2 times with 14 left. Bring down the 0. 18 goes into 140 7 times with 14 left. Bring down the 0. 18 goes into 140 7 times with 14 left. Notice we've started forming that repeating pattern. The 7 is the repetend that repeats. So as I write my answer, I put the bar only over the 7 because that's the only digit that repeats. The period here is 1 because I have only one digit that repeats. Let's look at part C. We have 1 divided by 7. So 7 goes into 1, and my decimal place goes after the 1, and I write several zeros to the right of that decimal place. Line up your decimal places. 7 does not go into 1, so we have a 0 in the ones place. 7 goes into 10 one time with 3 left. Bring down the 0. 7 goes into 30 4 times with 2 left. Bring down the 0. 7 goes into 20 2 times with 6 left. Bring down the 0. 7 goes into 60 8 times with 4 left. Go ahead and write another 0 and bring down that 0. 7 goes into 40 5 times with 5 left. Write another 0 and bring it down. I'm going to have to move to the right as I continue my subtraction because I'm running out of room. But 7 goes into 57 times with 1 left. Bring down your 0. 7 goes into 10 one time with 3 left. Notice that we're starting to repeat here. The digits that are repeating are 1, 4, 2, 8, 5, 7. And so the bar goes over all 6 of those digits. And our period here is 6. Join me in the next video as we look at writing a repeating decimal as a fraction.